Hello everyone. So this is the same page. This is page 56, practice 3a. We solved question number 1. We found a and b. Now we will go to question number 2 on practice 3a. Let's start solving this question. So let me read it first. A 2.8 kilogram rectangular air matrix is 2 meters long, half meters wide, and 0.1 meters thick. What mass can it support in water before sinking? So we have the mass of the matrix, which is 2.8 kilogram. We have the dimensions of the matrix, which will be important for us to find volume. Just multiply all those three numbers together: length divided by multiplied length multiplied by width multiplied by height. You will find volume. And then it says what mass can it support? That means we have an external mass, an additional mass. We have to find this additional mass. And then it says before sinking. That means our object is not sinking. It says before sinking, all right? So this is an important information. If you have an object that's not sinking, that means it's floating. And if something is floating, that means the F net is 0. Now this will be very important for us to know that the F net is 0. Okay, so let me write down the given here. So the given is, I had the mass of the matrix. I'll just write down M matrix. Okay, that means the mass of the matrix, which was equal to 2.8 kilogram. Now in the question it doesn't say that this is the mass of the matrix, but when I see kilogram, the unit, then I know this is mass. Okay, then we have the dimensions, and for the dimensions, first I had L, which was 2 meters long, and then I had width, which was half meters wide, and finally I had a thickness, which means height. Thickness, it means height, so it was 0.1 meters thick. Alright, so I'll combine all those informations, and I will get volume if I just multiply all the three together. And if I multiply all the three together, let me just multiply it here in this corner. Okay, 2 multiplied by 0.5 multiplied by 0.1. The answer that I will get will be volume, and it is 0.1 cubic meter. It is cubic meter. So this is the answer for volume. This is my volume that I will use in this solution. All right, so let's start the question. These are the information that I have. Yes, I have one extra information. Because this matrix is in water, then that means I have the density of water as well. This is also another given, the density of the fluid, okay, which is water in this case. And we know what the density of water is. It's 1000 kilogram cubic meter, right? So this is another information that I have. So I have volume, I have the density of the fluid, and I have the mass of the matrix. Now, as I told you, so what is the unknown, by the way? The unknown is the additional mass. We have an additional mass, which I will call it M capital, all right? What is the additional mass? This is what I'm trying to find. So let me draw a picture of what's happening here in this question. First, you have water, all right, and there's a matrix on top of this water. So this is my matrix, all right, and someone is a mass, an external mass, an additional mass is on this matrix. It could be a box. So I'll just draw a picture of a box here. There you go. We have a box on top of the matrix. I would like to find the mass, M capital, of this box. Okay. And this matrix is floating because in the question it says before sinking. So if something is floating, that means F net equals to 0. And if F net equals to 0, that means buoyant force is not winning, Fg is not winning. That means weight and buoyant force are equal. None of them are winning, so that means they are equal. And this is the equation that I will use. This is the equation that I will use in this question. So let me write down the equation here. This is my equation, Fb equals to Fg. All right, so usually buoyant force is exerted by the fluid. So that means this information that I have is for the fluid. Okay, so this will be mass of the fluid multiplied by g. This is the equation for Fb. Fb equals to mg, right? Mass multiplied by gravitational constant. So this this mass, I'll use mf, the mass of the fluid. Of course, the mass of the displaced fluid, because I cannot take the mass of the whole ocean or whatever. And then I have Fg, which again, Fg also equals to mg, both of them equals to mg. But this m here is the mass of the object, okay? Mo, I'll just call it Mo, the mass of the object, because Fg usually deals with the weight of the object. This Fg is usually for the object. This Fb is usually for the liquid. All right, and then multiplied by g. Okay, so what is the mass of the fluid? Let's put down the numbers in. What is the mass of the fluid? Well, I don't have the mass of the fluid. If I look at the given, I have the mass of the matrix, I have the volume, I have the density, but I don't have mass of the fluid. So what I will do, I'll change the equation for mass in order to find mass, because I have the necessary parts to find mass. So then mf will be rho f, this is the equation for mass, multiplied by v, all right? Multiplied by v. And finally, I'll just write down my g here. Okay, now I can find mass. I have the density of the fluid here. I have the volume here. I'll multiply them together and I'll get the mass. And then this equals to the mass of the object. Now here we have two objects. First, I have the matrix. And second, I have the external mass, what I'm trying to find. So I have to write down two masses, okay? This mass will become two masses because my object is not one object, it's two objects, right? So I'll write down two things. First, the mass of the matrix plus the mass of the object, all right? So the second thing is the mass of the object. And finally, multiply all of them by g. Okay, so we changed this MO, the mass of the object, into two masses because I have two objects. I don't have one object. All right, so one thing here, I've got G on the right side. I've got G on the left side. I can I can divide both sides by G. So this G will cancel with that G. Okay, so this will make the equation look simpler. I will have rho F here multiplied by volume equal to m of the matrix, the mass of the matrix, plus the capital mass, the external mass, which we called it the box, the mass of the box here. Okay, so I'll take this mass of the matrix to the other side so that I can find the external mass. So I'll single out this one, this will stay here, and this mass of the matrix will go to the other side. And because it's positive, once it goes to the other side, it will become negative. So this will be rho F multiplied by V minus, okay, minus, it was positive. Once it comes there, it will become negative, minus the mass of the matrix. And this will equal to the additional mass. Just insert the numbers and you will get the answer. So the number here for the density of the fluid is, of course, 1000 because the fluid that we have is water. Multiplied by volume, we found volume, it was 0.1 cubic meter minus the mass of the matrix. What was the mass of the matrix? It was 2.8 kilogram. This will equal to m, the mass of the external object, which we called it the box. Let me see what the number will be. I have the number with me here. So I guess in this case the number for this external mass will be the number it will be 97.2 kilogram. So if you multiply those numbers together, you will get 97.2 kilogram. Okay, so this is the final answer. Now we found what the mass of the box is, of the additional mass that can stay on this matrix without sinking. this matrix can support 97.2 kilograms before it can sink. Alright, so this is the final answer. Very simple. You just first multiply FB by FG because your Fnet is 0 because your object is floating. Change MF because you don't have MF, the mass of the fluid, into the mass equation. You have the necessary parts, so you don't have any problems with the left side. And on the right side, you have the mass of the object, but we don't have one object, we have two objects, so I have to change my mass into two masses. Mass of the matrix plus mass of the external object. And then that's it. Just take the matrix to the other side, put the numbers back in, and this is the number that you get. One final tip before I end this video. Some students asked in the class, well, teacher, this is mass of the fluid, so when I change it, it will become the density of the fluid multiplied by the volume of the fluid. But this volume here is not for the fluid, as you can see. It is the dimensions of the matrix. So if I find volume, this volume should be the volume of the object of the matrix and not the volume of the liquid, not the volume for the fluid. Well, this is a good question, but the volume of the matrix is equal to the volume of the displaced fluid, because the displaced fluid, which in this case is water, depends on the volume of the matrix. So that's why they are equal. Volume of the matrix equals to the volume of the fluid. So I can use this volume for the volume of the fluid, and I can use it also for the volume of the object. It can work for both of them. So I guess that's it. If you have any questions, let me know. I hope that was clear. Alright guys, good luck.